Okay, first task is to rewrite this general equation into a standard form or vertex form. So that's where I want to do completing the square. Oops. Alright, so that's x squared plus 4x plus something, and a plus 1 there. Okay, so let's see. I want to take the 4, divide by 2 to get 2, and I want 2 squared, which happens to be 4. So if I add 4 on the inside, and to keep it balanced, I'm going to subtract 4 on the outside. So in rewritten form, I get x plus 2 squared minus 3. Alright, a in this case would be the number out front, so that'd be 1. H is the x-coordinate of our vertex, so that's opposite of what we see, negative 2, and then minus 3. So, kind of get some ordered pairs, and then, well, we can plot that. So negative 2, negative 3, negative 2, negative 3 puts it right there. Alright, so just write that there. Okay, the y-intercept, yeah, well, let's do the x-intercept. Okay, so now that I've got it in vertex form, I can just set that form equal to 0 and solve. So I'll bring the 3 over, and then we'll do the square root. Alright, so negative 2 plus or minus the square root of 3 equals x. So my two ordered pairs that it crosses the x-axis at would be negative 2 plus or minus the square root of 3. Okay. Y-intercept I get by going to the original and plugging 0 in. So 0 squared plus 4 times 0. Hopefully you get 1 out of that. Alright, so let me kind of plot what I got so far. 0, comma 1 for the y-intercept. Alright, so let's kind of talk this through for a second. Square root of 3. Let's see, well, square root of 1 is 1. Square root of 4 is 2. So square root of 3 is somewhere in between. It's kind of estimated as 1.5. That's fine. So if I take negative 2 plus 1.5 and negative 2 minus 1.5, I get something between, so you get around half, right? And then I get around negative 3.5. So right about there. And that kind of fits what I visually see in the picture there. So I'll kind of draw those. Trying really hard to make it smooth, curve-ish. Alright, domain, no restrictions. And then range, I can see the graph doesn't physically start till negative 3. Alright, there you go. Okay, we have another just sort of practice on quadratics. Alright, so we want to do completing the square again, put it into standard form or vertex form. Actually, I want to factor out that negative 2. So it's x squared minus 6x plus something plus the 12 at the end. Okay. So let's see. So if we take the negative 6 over 2, we get negative 3. And negative 3 squared equals 9. Okay, so I'm going to add 9. But that's not really what I added. So if I take that negative 2 and I distribute it in, I really subtracted 18. So to balance it, I want to add 18 to that one. Okay, so then from here, when I put it in put it back into vertex form. So negative 2 x minus 3 squared plus 30. Okay, so our, let's see, a would be negative 2, h would be 3 in this case, and k would be 30. So the vertex is at the ordered pair 3, 30, which makes me a little nervous looking at my graph. I think I came up with a question before I bothered to look at the grid, so we might have to draw our own grid, but that's okay. X-intercept, okay. So I want to take my vertex form, set that equal to 0 and solve. So x minus 3 squared plus 30. So if I bring the plus 30 over, it becomes negative 30. And then I want to divide by 2, which gives me positive 15, equals x minus 3 squared. And then square root of that, so plus or minus the square root of 15 equals x minus 3. And then add 3, so 3 plus or minus the square root of 15 equals x. And that's a lovely ordered pair. Sorry, not 5, 15, comma 0. Okay, y-intercept, so put zeros in, I should get 0, 12. Domain and range we'll look at the graph from, and I'm just looking at the size of my numbers in my little grid here. You know, the easiest thing to do, just change the scale. That's what I'm going to do. I don't know if that makes it a little bit better or a little bit worse. We'll kind of see here. All right, so 3, let's see, so 0, 12 would put it right above there, the way I've got mine set up. And the vertex at 330 would put it right there, actually, yeah. It's a little off to the side. Square root of 15. Let's see, square root of 15. It's really close to square root of 16. And that square root of 16 is 4. So if I treat that to be 4, so 3 plus 4 and 3 minus 4. So that means I've got one x-intercept at around 7. And I've got the other one around negative 1. So, I don't know. You know, it's kind of a toss-up. Me switching the numbers. Now it's got a really tiny graph, really tiny picture for a big graph. But I got enough information now that I can kind of see that it's going down a little skinny parabola. All right, now as far as domain goes, no real restrictions. And this time I can see that it starts at negative infinity as far as range goes, and the y values stop at 30. And so that you should see a connection between the range and your vertex. All right, number 3, let's see, first task is to find the degree. And it's not a third degree, by the way. It's, let's see, so it's an x with a 3 plus 2. So it's actually a fifth degree. Leading coefficient, there's a bunch of 1s that I'm multiplying together, so it's a leading coefficient of 1. So if you were to multiply it all out, just imagine your first term would be x to the 5th, and there'd be a 1 there, so it'd be 1x to the 5th with something to the 4, you know, x to the 4th with something. The other positions are probably going to have other than 1s on them, but I can see that that's just going to have a 1. End behavior, it's a fifth degree, so that's the first and the third quadrant. Zeros, noting multiplicity. Okay, so I know it's, if I look at factored form, x cubed, if I set that equal to 0, that gives me 0, and it's got a multiplicity of 3, and let's see, the minus 2 is going to cross at 2, 0, and it's got a multiplicity of 2. And I think this x-intercept question is just a silly repeat, since I already identified the zeros. And the y-intercept, so imagine if you were to put a 0 in, what would you get? We actually would get 0, 0 out of that. Okay, so at this point we're going to plot all of we know, I know it goes through 0, 0. I know it goes through 2, 0. I also know that it's got to go up in the first, and it's got to come down in the third. And because of multiplicity, I've also got a couple of rules. So I know it's got to bounce at 2, and it's got to wiggle through the origin. So all I have to do is connect all of those little facts together. So it's going to have to turn around somewhere and go out that way. So that's our picture of number 3. All right, number 4, degree. Okay, so let's see. We got 1 plus a 1 plus a 2. So that's x to the 4th. Leading coefficient would be a 1 again. Again, think about multiplying it out, what the first term would look like. So an x to the 4th would be an n behavior of first and second. Zeros noting multiplicity. Okay, so we have 3, 0. It's got it's a singularity, so there's only one root at that number. Negative 1, 0 has got only one root at that number. And 5, 0 has got a multiplicity of 2. And again, I feel like I'm just repeating my question here, but anyways. Okay, y-intercept, y-intercept. All right, so put a 0, and a 0 in there. So that would give me 3 times, that would give me a negative 3 times 1 times, and that would give me a 25. Okay, so that gives me a negative 75 as far as the y-intercept goes. Okay, well, it is what it is. All right, so let's see if we get this. So it's way, way, way off the screen. Down here at negative 75, I have a y-intercept. Then, let's see, I got 3, 0 right there. Negative 1, 0 right there. And I got 5, 0 right there. And I know it's first and second. Let's see. Starting with the leftmost. So the 5, 0 is going to have a bounce. That's going to have a wiggle. It's going to be, at that point, I know it's going to hit here at some point. Have to turn around, which means it's going to be below the x-axis when it comes here. So it's going to have to cross somehow like that. Okay, so next task is to connect the information in a somewhat smooth and continuous curve. Gonna have to turn around and then bounce. Okay, so our graph looks something like that. All right, so number 5, the intention behind this question is just kind of remind you what all different things we can use synthetic division for. Obviously division, but as far as this review goes, I'm just reminding you of the big picture. Whatever I'm going to ask you to do is going to be some sort of theory-based question on dealing with synthetic division. So you do want to kind of review what synthetic division can be used for. So let me kind of make it just a quick list. We can use it for division. That's what the title says. We can actually use it for functional values. We can use it to find remainders. And then we can also use it to find oblique or slant asymptotes in a rational function. So those have been, I guess, the 4 main things that we've ever used synthetic division for. So if you're drawing a blank on any of that about how that would be applicable or come up, I would review your notes and make sure that whatever I ask, you're able to demonstrate how synthetic division can make that process, how that process works, or at least make it better, I guess. All right, number 6, we are given some information about a polynomial, and we are to write it out in factored form. So p of x equals, all right, so if x equals -4, the factor component of that, so imagine if you bring the -4 over, would look like x plus 4, and the fact that it's got a multiplicity of 2 means it's going to be squared. Then we have x equals 2 plus 3i, so that would be x minus 2 minus 3i, and they're telling us it's a degree 4, so I'm missing a factor, I'm missing a root, but luckily we have a complex conjugate theorem which says if one complex root is there, then its conjugate also has to be there, so we can actually add 3 minus I to the list. So x minus 2 plus 3i would be the other form. Now notice, highlighted, very clear, stop. At that point, that is the answer. That's all I wanted on that one. Going down to number 7, find a polynomial function of degree 4. So notice 6 and 7 feel very similar to each other. I went out of my way in number 6 to say, do not multiply, leave it in factored form. But clearly, I missed the boat on number 7, right? No, I actually want you to multiply it out and see what the original polynomial was. So let's start by putting it in factored form first, and then see what we have. So that would be x minus 5 squared. This would be x minus 1 plus I, and its conjugate also has to be a root, so x minus 1 minus I. Okay, so now the task becomes, let's multiply. I'm going to suggest let's start with the I expressions, and I'm going to kind of scoot this over to the side here and kind of work on the side. So x minus 1 plus I times x minus 1 minus I. Okay, so I'm going to do a triple distribute here. X times x is x squared. X times -1 is negative x. X times negative I is negative ix. Yay. Then I'm going to move to the -1. So -1 times x is negative x. -1 times -1 is positive 1. And -1 times negative I is positive I. Now notice I've sort of lined up like terms and I've kind of left space for things that aren't alike. Brings us to our last example, last thing here, I times x, so that's plus ix. I times -1 is negative I, and plus I times negative I is minus I squared. Alright, so that's x squared minus 2x. The ix's are gone. Plus 1. The i's are gone. So minus I squared. Now hopefully your math senses are tingling because I squared is actually -1. So I can swap that out with a minus a -1, which is really plus 1, right? So those together become 2. So coming back over here, we have x minus 5 squared. Well, we'll do that in a second. I have x squared minus 2x plus 2 is what that part simplified down to. And then we can take care of the x minus 5 because that part we've seen enough. We can do that in our head. That's x squared minus 10x plus 25. Okay, now we're not done yet, but at least it looks prettier. So we managed to get rid of the i's. This is what would be called factored form then, with the original being the complex factored form. So now I just want to multiply that expression out. So x squared minus 10x plus 25. Okay, let's come over here. Okay, so just like we did a second ago, we're going to triple distribute. So x squared times x squared is x to the fourth. X squared minus 2x is minus 2x cubed. X squared times 2 is plus 2x. Then we got minus 10x times x squared, so that's minus 10x cubed. Minus 10 times negative 2x is positive 20x squared. Sorry, I just realized I missed the number, plus 20x squared. So minus 10x times 2 is minus 20x. All right, 2/3 there. All right, last one. I got this. 25 times x squared is 25x squared. 25 times negative 2x is minus 50x, and then 25 times 2 is plus 50. So the nice part about lining them up, I can see very quickly who combines. So x to the fourth minus 12x cubed plus is it 45, 47 x squared minus 70x plus 50. Okay, and so that is our polynomial. It's the original p of x. All right.